OWASP Birmingham. I'm Tom, and we also have Ian here. We're the two chapter leaders who are here. There are some others, they're not here. So we've got 3 talks today. I'm going to be giving a talk, Ian's going to be giving a talk, and the gentleman in the back, I can't pronounce his name, is it?
Uzi.
Uzi, is that right? Yes. Uzi's going to be giving a talk as well. Hopefully you'll enjoy it. Any questions, we definitely encourage you to ask them. And, you know, probably going to go for beers after this. If anybody's up for beers, it's probably the best thing to do after something like this. After everything. In case of a fire, which is put a down on everything already, but in case of a fire, go out this way, down the reception, through the car park, and into a corner, I was told. We will be having food. You said it'll be coming about 7:30?
7:30, there will be pizza.
Cool. So, has everybody been to an OWASP event before? No. Okay. So OWASP stands for the Open Web Application Security Project. It was a project that was started by a bunch of Americans. Well, actually, that was a lie. There was some English people involved as well. To kind of like spread the news about web application security and all of the problems that clients were facing or end users were facing. So the idea of these chapter meetings is that we will be sharing knowledge that we have in the web application security space to help people who know about web application security, people who don't know about web application security, and also people who, you know, have never even heard of security before in their lives. That happens quite a lot of people come along and they don't know anything about it. So it's quite interesting for a lot of different people. There is obviously everything's free, it's open source, all of the projects. There is the chance to be a member. The membership costs $50, I think, a year. Is that right?
30 quid at the moment.
30 quid, okay, so about 30 quid a year. You don't have to be a member. The only reason that you're encouraged to be a member is get a nice OWASP email address, which was one of the reasons I did it originally. And the next reason as well is that proceeds go towards your chapter. So if you put down Birmingham chapter, we can then use it for getting food if we don't have sponsors.
Birmingham UK.
Birmingham UK, that's right, yeah.
I made that very clear.
We do have a sponsor today, and all the food is coming from this gentleman over here. So if you want to thank anybody, thank this guy here, and that's Hedgehog Security, right?
Yep, that's us.
Great. So, without taking too much more of your time, I'll let Ian start. And Ian is going to be speaking about learning web application security. So, good luck, Ian.
Thank you. Okay, my name's Ian. I'll be talking about learning web application pen testing from a noob's perspective, which is what I am. Using free tools to learn and practice common web application attacks such as cross-site scripting, SQL injection, and I'll be doing a command injection example as well. Next slide. Right, who the hell am I? My name's Ian. I am at Fisherman's Enemy on Twitter and Xbox Live, if any of you are on there. I've been doing IT for about 20 years. Shows how old I am. I started off doing a BTEC National at Halesowen College back in '93. I had a part-time job at Icon Computers in Dudley, fixing computers. I went to Birmingham University for a year and then ran out of money. So had to then drop out and get a real job. So I ended up at PC World.
Ooh.
Wow. I had enough of dealing with the general public after 2 years of that, and I then went and got a job at the MEB, the Midlands Electricity Board, doing Wintel server support. Back in the days when we also ran OS2 Warp on a token ring network. That was interesting, learned a lot. We got bought by National Power, so then I worked for npower from the same desk, doing Wintel server support. I then moved careers slightly to go into software packaging and software delivery. So basically getting software out to the npower estate, so that was interesting. And then finally moved over into security 5 years ago. So I'm actually fairly new to the security business. hence the need for perspective. The first time I got an inkling that I might enjoy doing security was when I was actually doing my software packaging and delivery, because I knew a little bit of programming and a little bit of scripting. We were asked to help track down someone who was harassing one of our employees over email. They wanted to find out if they could trace who was sending an email from a Hotmail account. They thought that the user might actually be internal to the company. So what I ended up doing was setting up on our network an Apache web server, hosting a single pixel GIF file, and then sent an email to the email address that was harassing our person, saying, "Hey Dave, long time no see," pretending it was just a miskeyed email address with a link to the GIF file. Sent it. 6 hours later, Apache log popped up. Internal IP address had tried to resolve that GIF file, and then we tracked him down. And that was like, that's pretty cool. I think I might be able to do this for a living. So we eventually moved over to security, which is where I've been for the past 5 years. And I've been breaking stuff pretty much since I was 2 years old. So if you ever get to meet my parents, ask them about the Lego in the VCR. They've not let me forget about it yet. Right, why in a shall listen to me? Well, yeah, I'm a noob. I've been doing security for 5 years. I've been looking actively at web app security for about 8 months. I've started my own program of self-driven learning because training's expensive and I haven't got any money. So the best thing you can do is try and learn it yourself. Birmingham is a huge city, but I found when I was trying to learn security that there's not a big security community here. There's a big security community in London, there's a big security community in Manchester and Leeds up north, but there was nothing here. So I thought I'd try and hook up with an organisation like OWASP, we can get a local chapter going, get some contacts and learn from my peers. So that's what I'm here. I want to learn from my peers, I want to learn from you, and hopefully I can learn some stuff and pass that on. As Gandhi said, be the change you want to see. Is every slide type going to be a question? No. Right, on to the meat. Introducing the damn vulnerable web application. Web app security is a tough thing to learn if you can't practice. Now, with other fields of security, you can just fire up a vulnerable app and crack on. But if you try and do that on Amazon's website, you're going to get in trouble. They're going to throw you in prison. So you need some kind of framework that you can practice your techniques on without getting thrown in prison. So, Damn Vulnerable Web App was created by, sponsored by the Random Storm people, I believe.
A guy called Ryan Dewhurst.
There we go. So people can actually fire this vulnerable web application up and have a go at it, practice various techniques, see what they can get away with. And obviously, it's legal. Another good feature about the Damn Vulnerable Web application is not only is it designed to be vulnerable to attacks, it also has multiple levels of security implemented in it. So you don't just get a raw form that you can inject SQL into and feel like a boss. You can then ramp up the security and have a look at the different mitigations that commonly you'll see on the internet. The developer will put a mitigation in, a little bit of filtering, think he's done security and walk off, and you'll actually find those on the internet. So you can then practice using these techniques against filtering that you will see in the wild or on a pen test if you actually go and do this as a career. Right, what is Damn Vulnerable Web App and how do you install it? Well, it's basically a zip file. It's a zip file of a zipped up website and you drop it on a web server. It's that simple. You download it, you unzip it to the root of the web server, you point your browser at it and you're good to go. It needs a MySQL database in the back end. But as long as you've got a database engine on your box, you just click a button, and I'll show you that in a second, and it will create all the tables you need to crack on. So it's actually fairly simple. And if you look, this is the configuration of it. Just click on the setup button, click create reset database, it populates the database with all the tables, and then you're good to go. Right, but that's hard. You need to set up your own machine, you need to install Apache, you need to install MySQL. That's a lot of work. We don't want to do that. So you download from the website an ISO file, which is a pre-built Linux environment with the SQL database on it, with my runnable web app and Apache, all rolled up and ready to go. All you need to do is boot it, and that's it. You don't even need to log on. Point your browser at it, and you're good to go. The previous slide, I said you could put it on anything. Don't put it on a public-facing web server, because it will get owned within about 10 minutes. Someone will come along and take over your box. Right, what vulnerabilities does downrunnable web app allow you to practice? Brute forceable authentication, command execution, cross-site request forgery, file inclusion, SQL injection, including blind, file upload, and cross-site scripted, reflected, and stored. Pretty much all of the common application vulnerabilities you'll see all over the internet today. Most of the OWASP top 10 are covered in what it will allow you to practice. No crypto, but we're talking about a learning environment. If you're at the point where you want to do crypto attacks, then you're at the point where you can start building your own environment to try those out. I'm going to look at two of the big vulnerabilities that you'll see on the internet: SQL injection and cross-site scripting, and one that you probably don't see a lot of, and that's command injection. SQL injection is a particular favourite of hacktivists and script kiddies, and you'll notice that most of the attacks that LulzSec and Anonymous like to crow about were done through SQL injection. Okay, time to have a play. Let's have a go at some command execution. So here we have a website that will allow us to put an IP address in, and it will ping it for us. That's very nice. It might sound like a convoluted example from DVWA, but this functionality isn't a million miles away from the kind of functionality you'll see on sites like whatmyip.com, and is it down for everyone or just me.com. All of these will go and do operating system level actions on your behalf and report the results back to you through a web application. Right, how it's supposed to work. Takes an IP address from the user, it then passes this IP address to the web server, gets it to ping that IP address, and then passes the results of that command back to the user. As we can see here, the results. Quite obviously the results of the ping command straight from the OS. Obviously it's also straight from Unix. Mostly you can tell that just because of the layout of the actual command output. Is there anyone here who can see another giveaway on there that will give away that this is actually running on a Linux box? Not you. Pete?
TTLs.
The TTLs. TTL is 64, that's a Linux box. Running on Windows, you'll probably see 128. Unfortunately, there's no prizes for this talk. Maybe a couple down the road you'll get a USB key.
You get pizza.
Yeah, you get pizza. There we go. Right, so what's it doing? It's passing user input to the command shell on the operating system. It's passing it as a parameter to a system command. And we can use this to inject our own commands and view their output as well as the output of the ping command. Say hello to OWASP top 10 A1 injection, which is what all of the vulnerabilities we'll be looking at today are covered under. Right, let's have a look at the source. If you look at the PHP code that comprises the page, you'll see highlighted in red the code that's vulnerable, and you can see it's actually in two places. The application will check to see if it's running on Windows. If it is, it will just execute a ping. If it's not running on Windows, it will execute a ping, but it will make sure that it only tells ping to do 3 iterations. If you do ping on Unix, it'll go and ping forever, and the application will only get to the point where it will report the results back. One thing to note, the user input is not being checked to make sure that it is 4 octets of numerical data, and it's being concatenated straight onto the end of a string using the button. Now, you can look at this code from the server itself. You control the server that the web app's running under. You can go and look at the PHP that comprises the page you're attacking. But if this was on the internet, obviously you don't have that option. I'll get to that later. Now, downrunnable web app has an option on it. On every page that you are trying to run an exploit on, there's a little view source button. You click that, the source will pop up in a menu for you. So you don't even need to start swapping screens. You can do it all from within the app. Right, let's add some extra commands to it. Right, so the PHP code is taking the user string and adding it to the end of ping. We can supply an IP address, the command separator, which is, hold on, just here, and in this case we'll send an ls-la, a simple directory listing to list the current directory contents on the web server. We have an effect here, a non-interactive command shell running on the web server under the privileges that the web server is running under. We can use this if we wanted to deface the site, change any files that the server has access to. This is a common tactic for hacktivists. If they get a SQL injection on your site, one of the first things they'll do once they've had a look around to see if there's anything interesting to pillage is to go and deface the front page saying, well, Tech was here, you've been owned. Right, here we can see the results of our injected command. You see it's still executing the ping, there's nothing we can do about that. But straight after that you'll see he's doing an ls for us, and there's the current directory. And you'll notice, oh dear. Right, okay, the command injection example so far was with the low security option, using very, very vulnerable code with absolutely no filtering at all. And the DVWA has 3 different security levels that you can practice against. As I said before, low security level really should have been no security because there really isn't anything on it. Right, low, medium, high security. Low security, no filtering. Medium security is basic filtering, and in this case it's filtering that developers would have read about or told they need to do. And they put it in and they think, great, job done, I'm secure. Not quite so much. The high security filtering is, I had a go, I mean obviously I'm a beginner, I said this at the beginning, I had a go at a couple of the high security modes on it, and even looking at the source I couldn't figure a way of getting my stuff past it.
So it's supposed to be unbeatable.
There we go, I don't feel quite so bad now. Bypassing a filter, if you switch it up to medium, is actually a pretty good feeling. If you've never done it before, if you're new to this, you crank it up to medium, fire your exploit at it and get nowhere like you did at low security. The second you actually manage to get past the filter, that's actually a cracking feeling. Not as good as, you know, seeing kids for the first time, but it's got to be close, a close second with the first time you ever run MSO at 067. you can't beat it. Right. Testing apps isn't always about attacking them from the outside. A lot of businesses, and because we're all concerned about cost, will let you look at the code and do a code audit because, you know, it doesn't take quite so much time. It's a useful skill to be able to identify vulnerabilities from the outside, but it takes a lot of time, it takes a lot of effort, and sometimes companies just don't want to pay the money. They say, right, here's our source code, have a crack, see what you can find. It's also a lot easier to identify some vulnerabilities that are hard to detect from outside the web application. For example, if user input's being taken, stored and used elsewhere in the app, such as an admin console that you might not have access to. You might not have been able to elevate your privileges, but there's a website administrator that can maybe view and edit your comments. If you can get cross-site scripting in there, you can own the admin console, and that might be very hard to identify from an outside test. Okay, to access the code in the app itself, just click on the view source button, as I said earlier. Click compare, and nobody sings the song from the insurance advert. If anyone even humming the go compare, out the door. Okay, and you can see the code for all 3 security levels. So not only the code for the level you're looking at, you can see all 3 levels at once. Again, without having to dig into the web server that you're hosting it on. It's very good to identify between the code examples what exactly they've put in. For example, // here. Try and defeat your attacks. Right, let's have another play. SQL injection. Everybody says SQL injection. It does what it says on the tin. It's injecting malicious SQL commands into the legitimate commands that the app is sending to the database. Right, this is how the developer wanted this to work. Form asks for a user ID. You put the user ID in and it goes and fetches the user's name, first name and last name from the database. Again, it might seem like a contrived example, but most intranet sites have a functionality for you to search their address books to find your colleagues' information, and this is exactly what this is. Also, applications that do any sort of e-commerce will ask you for a product number to do stock checking or product information. And that's exactly what this is. Right, here's the developer's here's the user ID for the user. Put it in, and it comes user ID 1, first name admin, surname admin. Developer says, great, that works, awesome. Right, the application is getting the user's first and last name from querying the database. The user ID is supposed to be numeric. The data the user is sending is never checked to make sure that it's actually numeric. If the developer is testing this and he sends a string of garbage into his query, it will come back with no data and no error. So he'll think it's working fine. Valid user ID, valid data, invalid user ID, no data. Works fine. So we can go home. Right. Testing for SQL injection. We know it's vulnerable to SQL injection because the page told us it's vulnerable to SQL injection at the top. But how can we tell that this form is actually vulnerable to SQL injection? There's lots of ways to test for it. Because this is an introduction, we're going to keep it simple. I'm going to look at one way that we can test this form to see whether or not it's vulnerable to SQL injection. Right, what we can do, we can start supplying valid SQL syntax in the user data. Strings in SQL are usually enclosed between quotes, either single quotes or double quotes. If you put one in, you can end up making the SQL query invalid. As we can see here, if we supply a single quote to the form, we get a nice, very helpful error message from the database. This is an information disclosure vulnerability because what the database has done is told us we're running MySQL. And it's vulnerable to SQL injection because it's giving you an error when you put valid syntax in. We know we're injecting into a string because we managed to trip it with a quote. If it was a numeric value, it would have been a different error message. We know the database is running MySQL. We can now refine our attacks now that we know we're not talking to an Oracle or an MS SQL database. That's going to come up later. Right. What can we send? So what can we actually use to get useful data out of the database? We can use a SQL union command to add our own query to the one being sent by the application. So this is the command we're going to send. Single quote, union select user, comma password from users where quote 1 quote equals 1, quote 1, no quote. The union command is useful to developers because they might want to query a database, they might want to query multiple tables that contain the same data, yet concatenate them all into one report. So that's why it's there. Right, we inject our command and this is what we get. User ID is what we sent in, so we're clearly just echoing our string. First name admin, surname, password. So they're storing them as, looks like MD5 hashes. We've now managed to get their password hashes. No, the sorting hat doesn't work on 30-year-olds. It was, yeah, it wasn't pretty. So what did the database see? Right, we can look at the PHP and see what statement the app was actually using. So it was using select first name, comma last name from users where user ID equals $ID. Our input made it select first name, last name from users where user ID equals nothing because we closed the quote. Union select user password from users where 1 equals 1. And now we have complete control of the database. You can reduce exposure to this kind of vulnerability if it exists by using restricted accounts in the web server that only have credentials to access the data that they're supposed to be querying. So if this was only supposed to be querying first name and surname, we only give it the credentials to do that, so if someone does inject SQL, they can't actually read any other parts of the database. Right, how did we make it a valid statement? We had to balance the quotes to make sure that the string was terminated properly. We had to leave out the last quote so that the quote that the statement was supplying at the end of our data has something to pair with. We also needed to query the same number of columns as the app, and that's something that's particular to the union statement that we're using. Right, how do we handle the trailing quote? Well, we could handle the trailing quote using the SQL comment syntax. In my previous example, I just did quote 1 quote equals quote 1 empty because they're both strings. What we could have done is just done double dash space anything, as far as MySQL is concerned, anything after double dash space is treated as a comment and the database ignores it. So we can change our statement to quote union select user password and users where 1 equals 1 double dash space. Now that space is important. That space cost me an hour of research because I knew that double dash was a comment, but I didn't know that MySQL needs a space after it, otherwise it ignores it as a comment. I've just saved you an hour, you're welcome. Right, okay. You might be wondering at this point how on earth I knew there was data in tables under a particular name in a particular column. If you were looking at this application from the outside, you wouldn't know there was a table called users, you wouldn't know there were columns called user and password. Even if you did find out that there was user table, how would you find out what the columns were to construct a valid query? Once you've established that there's a SQL injection vulnerability, you can query a MySQL built-in table to find the structure of the database. If your web app didn't have permission to query this table, then the attacker would be stuck because he would then have to brute force the table names and the column names in the database. A lot of effort. If he's only after low-hanging fruit, he'll probably take the time to move on. As we can see here, the table is called information schema.columns, and if you use your injection vulnerability to query table name and column name from that table, you will get a complete list of every table in the database and every column in the database. We now own the database. Right, I also mentioned that union has to match the same number of columns as the original query. It might be obvious from the output that you get from the app that it's querying 2 columns, but you can never tell. It might be querying other columns and just not reporting them back to you. First thing to try, just match the number of outputs you're getting from the database to see if that works. If that doesn't work, you can try making requests using null in the statement. We'll look at that now. So if we do a quote union select null comment space, we get an error message. The use select statements have a different number of columns. So it's already told us there's definitely more than one. We send union select null comma null comment. SQL executes without error. We get no data, but now we know we've counted the number of columns. And you can just keep adding nulls and see if you figure out how many columns are actually being queried. Right, let's change it up to security level medium and add some filtering. So we've got the low-hanging fruit. So what if the SQL developer had read about SQL injection and said, right, I'm going to do some content filtering. Let's crank it up to medium and have another crack at it. Right. The developer's read about SQL injection and knows that the quote character is equal, because that's how we managed to close his string and put our own stuff in. The dev also read, as I read when I was researching this talk, that if you pass the user's input through the PHP function MySQL real escape string, then you are completely immune to SQL injection. That's what the article said. Right. We'll pass our data through MySQL real escape string. We put our attack through MySQL escape string and we end up with this. It's escaped our quote by putting a backslash on the front of it. So MySQL doesn't treat it as a quote, a string terminator, and we get a big error message from SQL. Check the syntax. You've messed up. The database developer does this, and he goes, yay, I'm now completely vulnerable to SQL injection. Great. Not quite. Okay, MySQL real escape string doesn't take into account that most databases, including MySQL, will accept multiple encoding schemes. If we use the string char bracket 109, MySQL will interpret that exactly the same way as if we just passed it a quote. It sails straight by MySQL real escape strings because it's only interested in individual characters. So we changed quote for char 109 and our injection is now working again. Note we're up to security level medium, and it's quite hard to see there. Right, now that we're totally on the operating system and the database, let's move on to attacking the users. And this is where attacks tend to move from hack division and information theft attacks to the worlds of organised crime and all sorts of nasty like that. If you can attack every user that visits a site, you can install botnets, keyloggers, pillaging bank accounts, sell your botnets to your friends so they can DVWA the FBI or their website, because that's all they can actually manage to do. Right, reflected cross-site scripting. The first type of cross-site scripting is reflected. This is when data that the user supplies in his request is reflected back in the reply to. This is how it's supposed to work. Again, it might seem quite contrived, but there are plenty of examples out there where you put an input in, and as part of the response, you get that input reflected back at you, such as it searches, any kind of search will say you search for blah, here's your results, and there's your input. Right, user input rendered as HTML. The string that the user is supplying is sent back to them without any checks being made that the user didn't put any valid HTML in there. And this is where we get to the scripting in cross-site scripting. If we send a string that contains JavaScript, then this will actually be executed by the client as JavaScript. We send that string, we get an alert box. Pun. As you see, the script is being run, and they're getting
put that in a client.
I know people who have.
Don't use the word pwned in an actual client.
Number one.
Good point. Yeah. If you're still awake and have been paying attention, you may have noticed that we've shifted our examples from running a Chrome browser on macOS to running IE6 on Windows XP. And that is because modern browsers are actually very good at defending against reflected cross-site scripting. They will detect that the query you made contained the source of a script that it's now being asked to render, and it will refuse to render it. This little bit of information brought to you by 2 hours of me scratching my head as to why my cross-site scripting wasn't working. And eventually, Chrome has a very useful JavaScript console buried away in the bottom of it. That tells you why it wasn't actually working. So I'll just saved you another 2 hours.
Firefox will come up with a little red exclamation mark on top.
Yeah, it would.
Never testing.
Right, so as we're running the script in the context of the target application, we have access to all of the data in the DOM that's being used by the app, and this includes the cookie that's being used to maintain state. So if we send script alert document.cookie, we get pop-up with our session ID and our entire cookie. Great. That's not very useful. We already know what our cookie is. So how is this actually useful for an attacker? Right, how does the attacker actually get the data? If the attacker can inject a script that sends its cookie to a server they control, then it does become useful. So we use JavaScript to request a resource from an IP the attacker controls, fishermansanima.com. I'm not attacking anyone, just an example. We send this as a request. In my logs, I will see get PHP session ID, I will just see get request for that token. Now I can start pillaging you. You can also, if you want to, send it to a Netcat listener. The only thing to be wary of is if you don't send a reply, the browser is going to hang up waiting for somebody to come back, and it might actually tip the user off that something not quite right is going on. So the best thing to do is when you get the request, send something back so their session carries on through. So how do we get the user to send this script? Because they're not going to start keying JavaScript into a search query. We send them an email with a link. Phishing, it's how it's done. Send them an email with a link. They click that link. We pass the injected script as a parameter in the URL. Job done. Add cats, add lols, whatever pictures you need, they'll click it. Guaranteed. Right, store cross-site scripting. Sending these emails is a lot of work. You need to target the user's application. It's just a lot of work. If we can get the application to do the hard work for us, then it becomes even more powerful. So if we can get the application to store our script and serve it up to every user that visits a page, that's much more efficient. So popular targets for this kind of vulnerability are forum postings, blogs, social networking sites, anything that allows user input that's going to be rendered back to them. Twitter has had quite a few cross-site scripting vulnerabilities in its short time on the planet. So it's not just the small sites that are actually vulnerable to this. Here we can see a comment being posted to a guestbook on the app. Test, put a script in. That's it. The user just say it's a forum post. The user's complaining about the ending of Mass Effect 3, which I still haven't managed to get around to because I've been too damn busy. They post it up, but they get lots of traffic because people are searching for that kind of content, and they end up owning everybody that visits that web page. Malware, by the way, is actually being distributed using the Mass Effect 3 ending controversy right this second. Right, so when any user now navigates to that guestbook page simply by clicking on this link down here, the JavaScript runs, and as we can see, pwned. Once we've got their session ID, we can then impersonate them, we can start we log into the app as them, steal any private data they might have put into the application that you can't see publicly. If we manage to slip script to them via a vulnerable webmail application, we now own their email, which means we pretty much now own every account they own on the internet. And that's the holy grail if you're trying to attack somebody. Right, what are the payloads can you send using store cross-site scripting? Don't just set up stealing their sessions, send them a hook to beef, the browser exploitation framework. Pretty much a JavaScript implementation that will allow the attacker to then use your browser as his own and start attacking other clients on your network. Or you can point them to a machine running Metasploit's browser autopwn module, which will basically try and fingerprint the host that's connecting to it and serve up exploit after exploit after exploit until you actually manage to get one to run. You now owe the machine full compromise. And all this is from a simple cross-site scripting attack. So it doesn't take a lot to leverage. So, the summary. Downloadable web app gives you plenty of scope to learn and practice. The multiple security levels allow you to test bypass techniques, which are also important, to see how to defend against these attacks, which is even more important if you're a developer. And the best thing of all, you don't get thrown in prison. If you want to do your own self-driven learning on something like this, I can heartily recommend a book called The Web Application Hacker's Handbook. And this is a perfect companion to that for you to test out a lot of the techniques you'll read about. Again, there's no crypto stuff on there, but that's an advanced technique. Once you're at that level, then you're doing quite well. Any questions? Stunned silence. I'll take that. Anybody? Where's the pizza? Right, okay. The pizza will be here in about half an hour. Okay? So that's me. If you want to contact me, ianwilliams@OWASP.org. I paid my membership. I'm on Twitter at Fisherman's Enemy, and I have a blog at fishermansenemy.com. Thank you very much.
Was that as bad as you thought it was going to be?
No. Bunch of pussies.
We'll have like a 5-10 minute break whilst I set up my demos and stuff, and then we'll start again. Stealing my power bank.